So hello everybody, I'm Sergio. I am a high performance technical consultant for CharkNet. CharkNet is a regional partner within Compute Canada. For those of you who don't know, we are sitting in Ontario. I myself, I'm sitting in the University of Guelph. I'm a bioinformatician by training, biologist actually by training, bioinformatician by vocation. And I just want to make sure that you don't have false expectations. This is not going to teach you to do bioinformatics, like the general term. This is basically to help you navigate the first few steps before complex bioinformatics pipelines. And that's why it's just tips and tricks to make your life easier. And we're going to focus on three main formats, which is the Fasta file, the Fastq file, and tabular formats. All right, that's what we're going to do today. So with no further ado, let's get started. So for those of you, you might already know this, but just a quick refresh of the formats that we're going to be talking about. So the Fasta format is, it has this shape. It has a description line, which will have a greater than symbol starting in the line. And then it's going to have one or multiple lines of the sequence. And then the next sequence is going to start again with a greater than, and then it comes the sequence. So it's plain text normally to represent sequences of nucleotides or peptides. So protein or nucleotides. They are represented in single letter codes. So if you don't know what the codes mean, like you should go back or Google it, because we're not going to go into details of that. And it's often when you see Fasta files, you're going to see multi-lines that are normally wrapped at 80 characters. That's just a convention. There is absolutely nothing preventing you from having a single line Fasta, and actually there are some programs that require single line Fasta. Now, the other format that is very common, especially now with next generation sequencing, is the Fastq format. The Fastq format is also to store sequence. This is preferentially for nucleotides because it's mainly used, again, for next generation sequencing that sequence nucleotides and not proteins, although you might find some proteins encoded into a Fastq format. It will have also a description line, which normally starts with an @ right? And there's @ and the name of the sequence. Oftentimes, there are some conventions depending on the platform that you're going to use. So Illumina has a particular way of naming the sequences that will give you some extra information. Then it comes the sequence, and this in this case is just a single line most of the time. So the Fastq format is always, well, most of the time, 4 lines per sequence. You know that is 4 lines per sequence. Then there's a plus sign. The plus sign is it was supposed to get some information, extra information, and you can actually write whatever there. It's going to be ignored by most programs, but it's just to give more information about each of the sequences. Most of the time it's just empty, like it's shown here. So there's no need to worry about that. This one, there's a typo here, is not sequence, it's actually quality. This is the quality measure of this particular base. I'm going to talk about a little bit more about the qualities and how it's calculated. This is encoded into a single letter, but it represents actually a number. It's also done in plain text, although normally it is, because the files are quite big, so they're normally compressed. But you can, when you decompress it, it's actually going to be plain text. And is not wrapped. So again, this thing is just one line. Each one of the lines that you see in each sequence is a full line, no matter what the length. Normally, the length of the sequence is not very long, again, because it's next generation sequencing, with the exception of the 4th generation, the people that call 4th generation sequencing or 3rd generation sequencing, that they have a particular different format. Most of these are up to 300 characters, so normally they don't need to be wrapped. in any way. Now, what is quality and encoding in the Fastq format? This is sometimes a little tricky when you haven't when you're not familiar with the Fastq format. So the quality is basically the probability to be incorrect, to be the base call being incorrect. So if you say this is an A, an adenine, so what is the probability that I made a mistake, right? So normally it's in base 10. So the Q is basically minus 10 times the log 10 of the error, or the probability of error. So when you have a Fred score, that's how it's called, the quality is called the Fred score. If it's 10, you have 1 in 10 chances of being incorrect, and so on and so forth as you go up in the quality score. So a quality score of 60, you have a 99.99999% chances that the base call is actually accurate. But then you have this number, you have a 10, a 20, a 30 that you cannot put into a file that represents the same nucleotide. So for example, in here, this A, we could not put 2 digits here to represent this. So in order to do that, we have something that is called encoding. And the encoding depends on the Fred type. So for example, if you've worked with Fastq formats, you will see that there's 2 main Fred scores, the Fred 33 and the Fred 64. And what does that mean? So it depends on the ASCII characters. So ASCII characters are basically the characters that a computer can print, right? So it would start, the Fred 33 would start in the character number 33, and it goes up to about the character 73. The Fred 64 starts in the character 64, which is an at, and it goes up to the 104, which is an H, a lowercase h. So in this case, it's case sensitive. So uppercase A is actually worse than a lowercase h in the Fred 64. Currently, Fred 64 is the most used. So most of the time, you're going to be working with Fred 64. So that's basically how you encode that stuff. So just to make sure that you understand the ASCII characters. So there are many ASCII characters, from null pointers, so things that are not being able to print, to the basic printable characters, which are the ones that we start. That's why we are starting 33, if the Fred is 33. And it goes to 126. 126 is still a printable character, and it allows you to actually have a text file that you don't need to interpret in any way, right? And it also avoids accents and all that stuff, because not all systems can handle well accents. So we refrain from using those. So this is basically the space that we're using, either from 33 on or from 64 on. And the other very, very common format is the tabular format. So basically a table, right? Normally, a lot of people like Excel, and they will, so they are more familiar with the tabular format. So basically you have some field that acts as columns and is separated by a character. It could be a tab, like in this case, or it could be a comma, or if it's a comma delimited file, or basically any other character that we want to separate the columns from. So yeah, so for example, in this case is the output of a blast, of one of the particular formats of a blast search. So for those that are not familiar, blast search is an algorithm that will search sequences against a database of sequences. In this case, it's BLAST-N, so it's just comparing nucleotides against nucleotides, and it will give you, with this format, it will give you the first column is going to be the accession number, so the query that you're seeing, like the name of the query, then the name of the subject, or what is in the database. In here, you can see that oftentimes it's both the same. It's just because I just created a small database with the same file, so to be able to do it faster. Then the third one is going to be the percent identity because I'm telling it here. Then the query coverage, length, etc., etc. So if you want to, if you do not know all the specs of BLAST, you can go to their webpage and you'll see all the possible combinations of these things that that you can have. Now the terminal. Oftentimes, when you're not used to the terminal, it can seem as a daunting thing to do, but it's actually not that complex. You just need to get used to it and to get used to how to move around and how to deal with it. Why is the terminal important? First of all, most of the software do not have a GUI or a graphical user interface or the windows that pop up every time. Normally, most academic software, especially in bioinformatics, are to be run in the terminal. There are a few that are exceptions to that, but for the most part, this is how it is. And the reason for it is because the graphical user interface adds an extra layer of complexity for the person who's creating the code, who's creating the program, that do not bring anything else to the program itself. It's just an easy to use. It's more for the users than for the actual program. So most people do not go into that to make it easier, right? The terminal is also important because it's your first contact with the cluster, okay? So if you already have most of you must already have an account with Compute Canada, but when you interact with the cluster, you will interact through a terminal of some sort. And when you are inside of the cluster, you will have a terminal to use the command line and be able to interact with our cluster. The programming language that is normally used in like the environment that is used in most terminals is Bash. There are some differences of shells, but for the most part is Bash. So let's check it out in case you have not. So I'm going to just give like a brief tour for what a terminal is. So when you open a terminal, normally you will have the name of your computer and your username in the top, and then the path of where you are. What is a path? If you've never done this, a path is basically the direction of where we are in the system, right? In this case, this squiggly thing, the tilde, it actually means home. And then I am in a folder called playground, and inside this playground, there is a folder called sharknet, okay? So the first thing that you would like to do when you sign into a terminal is to know, first of all, where I am. So this already tells you some, but different configurations in different terminals will give you different results. So to be sure, you can always type, for example, pwd. This is the print working directory. So this work is the full path to where we are. So in my case, it's home, my username, and then playground and sharknet. All right. So this one is the first command that you can use to know where you are in the system. All right. Now the second command that is very useful here is list, or ls, right? This basically will just list all the directories and the files that you have in this particular location. Okay. And you're going to be using this quite often in our systems if you have not done yet. All right. Now, another one that might be important to you is to remove a file. Let's imagine that we created a file ld.txt, but we don't want it. So how can I remove it? Well, you can do remove ids.txt, and then the file is gone. Okay. Be careful when you use remove, because if you just create a file and then remove it, there's absolutely no way that we can retrieve it if it's very new. Some parts of Compute Canada clusters have a periodic backup, but it's not every day. So just be careful when using remove. All right. Now, another important command would be make dir. So if you want to create a directory, let's imagine that I don't want to work in this particular folder, which is Sharknet. I want to create my own folder within Sharknet. So I'm going to do make dir and then general interest. I already created it, so I'm not going to do it. But oh, actually, let's just remove minus rf. Watch out with this one. Minus rf means recursive. That means that it goes in a folder and removes everything that is inside that folder. And f is just force. Don't ask me if it's okay. Okay, so I'm going to remove this folder and I'm going to recreate it. So I'm going to do make dir, and then I'm going to just type general interest again because it's the general interest seminar. And I'm going to move into that folder. To be able to move into a folder, then you just do change dir, and then you do general interest. All right. So here is something like that. That is useful. Now, I am going to actually go out of this, and I'm going to show you also something that can be very useful, especially when you're working with files that are in a web, right? So for example, I have 3 files here in a web page, and I can just do copy link address, and I can actually download it directly to my terminal using wget, right? So if I just pasted the thing there, it is going to download it. And I can do the same for all the others. So as you see, this is a Fasta, and then I'm going to download a blast. And finally, I'm going to download a Fastq. Fastq can come with an extension that is called FQ or Fastq written all. Sometimes it's going to have a .gz. That means that they are compressed. All right, so now we have our 3 files already in our folder. There are modifications to the ls command to give you more information. So for example, if you type ls -l, it's going to give you a little bit more information about who's the owner, what are the permissions of that file, and the size in bytes. You can also, for example, add an h there, and it's going to give you the actual in kilobytes or megabytes or gigabytes, et cetera, et cetera. So you can see actually the size and when it was created. All right, so it's just to give you an idea of more stuff. Now, when you want to explore a file, you can use multiple things. I'm going to show you here 4 ways that you can explore a file. So the first one is you want to see just the first few lines. You can use something that is called head. And then when you do that, it's going to show you the first few lines. And you can control how many lines with the -n option. So if you, for example, you want only 5 lines of code of the file, then you will do it this way. If you want the same, but actually the last ones, not the first one, you can also do the same, but with tail. So instead of head, you use tail, and then you're going to have the last few lines of code of the file. If you want to just print everything that is in the file, you can use cat. Cat is a short for concatenate, but it also prints everything in the file. So if you do cat a Fasta, you're going to see that you basically printed the entire file. Okay, and why is it concatenate? Because you can actually, for example, if we do cat a Fasta and then again a Fasta, or actually just to, this will make no sense, but just for you to check, you can cat the blast. Right? With a blast, and then you can actually, like this one is just going to print both files at the same time in the thing. So this is the blast, and this is the sequence, right? But it's going to only be printed to the screen. If you want to actually save these concatenations, you will need to do something that is called redirect. So you redirect with the smaller than. That means that you're going to put something into the file. So this is like concatenated file.txt, for example. And when we do that, then we can actually explore it again with head, for example, or with tail. So we can see that we actually concatenated two things that make no sense together, but just to show you how to concatenate stuff. This one is kind of like tedious to be doing this if you want to explore the entire file or a particular line. So you can use, for example, more, and then the concatenated file, for example, and this will open the file for you to be able to explore it. So you can actually go down the file, you can go up, so you can keep going down the file until you reach the end. If you are in more, you can also quit more with Q. So you just type Q and you will be out of it. There is another one that is almost exactly the same, except that it allows you to do back and forth, which is called less. If you do less concatenated file, so again, we have the same thing, but we can go down and we can go up. And then as soon as we get to the end of the file, it's not going to exit. It's going to stop and it's going to tell us the end. If we want to get out, we just have to, again, press Q and we're out of that. Some of you might already be very familiar with this, but I just want everybody to be in the same page about how to explore things in our cluster or in a terminal. Another important thing is you want to edit something. So there's many editors. One that I find the most simple and useful is called Nano, and is in all our clusters. So if you do Nano concatenate, it's going to open an actual editor. So you can actually say, okay, I don't want this, for example, so I can just remove that. And then when I want to exit, it actually has a nice help right here. This caret here in terminal means control. So if you do Control X, is going to exit and it's going to say, do you want to save the modified buffer? And you can say yes. And then it's going to ask you, do you want it to save it in this particular file? And you just type enter, and then you can see that we actually have edited a file. Okay, that's basically it. Some basic bash commands that are going to come very handy throughout. Okay. So these are some of the basic commands. You have ls, cd, remove with C. wcount, I'm going to actually show a little bit more of wc. wc will count lines in a file, and it's going to also give you a word count if you want to. We already saw pwd, make dir, nano, wget, cat, head, tail, and more or less. So these are the most basic commands and the ones that you're going to be using very, very often in our systems, or in your own practice of bioinformatics if you have a terminal like a Linux or a Mac. And with the new Windows Linux emulator, also in that one. You have to know that if you're using Windows Terminal, the Windows Terminal is a different stuff, and these commands do not work on that kind of terminals. So I am sticking to Linux because it's the one we have in our systems. So you will have to do a little bit more digging for the Windows commands. All right, so let's start with dealing with tabular data. So I'm just going to show you a few things that sometimes you wanted to know and you didn't know how to do it in the terminal, because you can do this in Excel or whatever, but that requires that you have a graphical user interface, et cetera, et cetera. So the first thing is, let's imagine that we have a blast, the blast that I showed you before, right? That have 1, 2, 3, 4, 5, 6 columns with this particular set. Okay, so the query accession version, the subject accession version, the percent identity, the query coverage, the length, and the e-value. But can we subset those? So we don't want them all, we want just a few. How can we subset them directly in the cluster or directly in the terminal? Well, we can use it either with cut or with awk, all right? And how does that work? So let's see. Again, let's do a head of the blast. So we have this blast. I'm going to make it a little bit smaller right now, just for you to see tabular. I'll make it bigger again later on. So we have all this. Let's imagine that we only want the first one, the first one and the third one. So with cut will literally just cut based on tabs. All right. So if you do cut minus F means field, and then you say I want the first one and the third one, and then the name of the blast, right? And that's going to show you all. Okay. I'm going to be using something that is called a pipe just to show you better. Pipe, basically what it does is it takes the output that we just saw and is going to put it into another command that I'm going to type here. In my case, just a simple head, right? And then we just have a few lines to show. All right, so, and this can be done either in a range. Let's imagine that we only want from 1 to 3, and then we just have 1 to 3. Or you can just put multiple values here. All right. And if we want to create a new file with that, then we can actually do the redirection that I just already showed, right? And it's like 1 to 5, for example. And then I have 1 to 5. Of course, it's not exactly 1 to 5, but you get the gist of the thing. Basically, cut will cut in a particular in tabs. This is very important. It's only for tabs like this. But let's imagine that we actually have something that is not with tabs. I'm going to go later on that one. Let's imagine that you actually have a file that is with commas. So you can actually change the delimiter with the -d option. This will, instead of looking for tabs, is going to look for commas for the field delimitation. So if we do this, it's not going to work because I don't have commas in this particular file, so it's not going to cut anything. Okay, but if we had a comma delimited format, then we will have what we need. All right, so I show you here that awk is also a usage. awk is a more complex program, but you can use it in a simple manner. So for example, if I have awk and then I said print give me the one sorry, 3 and 5 as we had here, and we have that. Oh, it did not work. Okay. It's not working for me right now, but I'll go back to it a little bit later. All right. So this is basically the easiest way to subset columns is to cut. Okay, that's the basic way to do it. Now, what about if we want to just subset both columns and rows, right? So let's imagine that we just don't want this. Sorry, we want only these 3 rows, but we also want this column. So to subset these 3 things, well, that it can be done with awk. With awk as well. So let's see if it works, because it's not working for me right now. So in this case, for example, we want to filter only the ones that have SQ1, right? And then just print the fields that are in 1, in 2, and in 3. All right. So let's try it out. So the first thing that we want to tell is to seek for the SQ2, right? We have SQ2 that. So we're telling awk to look for that particular pattern. That's what this means. And then if we do that, let's see if it works, because I'm not sure why it's not working. I think I have a typo somewhere before. So now that we have here, is going to seek for SQ2 and SQ22. Well, that's not what we expected, because well, that's an unusual thing. But what we can do is to actually put the entire name here for now. The globbing in Bash can differ from machine to machine, and I tested this in another machine, so that's what is going on. So now we already have a filter of the lines that are SQ2. But if I want to print just the line, sorry, the column 1, 3, and 5. So I keep that one, and then I say, all right, print now, print 1, which is the field 1, 3, and 5. Wait, 5, and it just printed like that. But as you see, this particular one will not have any spaces. So if I want spaces, I will have to actually quote it. If I quote it, so to quote the spaces, sorry about that. You quote the space, so it's actually printed with spaces. In here, you can put other things. For example, let's imagine that you want a comma delimited print, and then you have a comma delimited print. All right. So in this case, just with a single command, a simple command, we search a file for this particular name, and then we subset the tabular format to work with whatever we want to be. All right. This is Awk is fairly powerful, but it can be a steep learning curve to understand because it has too many variables, and I'll show you some more complex ones later on. Okay. So as we see, we can actually filter columns by value, but can you actually do greater than something or smaller than something? And in fact, you can. So in this case, for example, I'm asking if the column number 3, so is this one, right? Which if we go back a little bit, column number 3 would be person identity, right? So this question is, if the person identity is greater or equal than 90, and then it comes to the 4th, which is going to be the, I think, what the next one? The query coverage, yeah. If the query coverage is greater than 99 and the e-value is smaller than 1 to the power of -70, then print the line. So if you saw, I use normally $1 for each field. If I use $0, it's going to print the entire line. Okay, so let's, I'm going to go out here. I'm going to just, because I'm a little bit lazy, so I am going to just copy and paste this into our thing. And the file is with a plus. And then we printed only the ones that follow this particular thing. So let's see, 1, 2, 3, 4, 5, 6, 7. Okay, I have a different file here. So let's adjust it to this file. So I want, this one is the query coverage. So sorry, the person identity. So this one is all right. Then 2, 3. I don't think I have query coverage in this. So I'm going to just filter by e-value and let's say, well, length is not a point because it's all is 300. Well, let's say that this one, I don't remember which column this is because this is a different file. So I'm going to say that the 4th one is actually 1, 2, 3, 4. The 5th one is going to be non-zero. Okay, so let's repeat that with the fifth one being greater than 0. So let's put greater than 1. And then we actually filter this column. And you can keep adding other columns here, right? So for example, if I add another column and I said, okay, I want the next column over. So 1, 2, 3, 4, 5, 6, 7, like 7 column to be greater than 1. And then we just have the ones that have 2. So you can subset very easily with awk directly, right? You can also search for stuff. So for example, let's imagine that I just want all these particular things, but I want first to search for this particular thing, this particular name. So if I do this, it only prints the sequence that will match this stuff. Okay, it will match our filter. Let's see what would happen if we just ask it to print this one. So we'll see that we have multiple things that do not match our filter. And with the filter, if we add the if, each field, and the particular numbers, then we can actually subset that. Again, I know that this is a lot to take in, but what I want you to get from this webinar, and then you can come back to it later, is where to look for things, right? So you know now that awk will allow you to do a lot of type of filterings, and that's basically the main objective of this. Another command that I didn't show you is clear. Clear is basically just to clean up the terminal. I use it quite often. So, all right, so we already did that with awk. Awk can be a very, very useful command in bioinformatics. Now, let's imagine that we don't like the tab delimited. The tab delimited format, it's a problem. We want to switch it to, for example, a comma delimited format, right? One note here in Unix, which is Linux and some Mac, the tab is represented by this. So this is kind of like a escape character and T. That means tab, okay? So we can use another command that is called set, right? I'm sorry. That is called set to do that. So set is to replace. Set is replacing a particular pattern. So you will need to use some pattern. So similar to what we were doing in awk with this, you can use any set delimiter, but we're going to use the /. So if we do, for example, set change, this means string. So it's going to be a string, change tab, and change it for a comma, right? And then we end with a G. G means all the occurrences of tab. And then we're going to do last. I'm going to just do the head. And we just replace all the tabs for commas, so you can actually export the file as a comma delimited format. All right. So set is going to look for any pattern that you want, and is going to replace it, and is going to print it to the screen. Now I'm going to just and then I'm going to do blast.txt because I want to show you something. Actually, the CSV. So I'm going to redirect this. So blast.csv, this is definitely not a CSV or a comma separated value. It's definitely a tab. So if I want to convert this one with set, so I just do the same that I showed you before, blast with CSV, and it will print that. But if I go again into blast CSV, this file has not been touched. So if I want to replace in place, I can use the command sed -i, okay? And in that case, now, this is a CSV file. And I can do this for a number of different things. So let's imagine that I want to replace, for example, size equals for nothing. I want to just remove the size equals nothing. If I do like this, it will remove the size dot equal. And you can actually do multiple manipulations like this, and it's going to be a lot more useful than opening a file in a text editor and go line by line looking for the patterns that you want to remove, right? There is, in bioinformatics, is often the way the names of the sequences are set causes problems for some programs. So knowing sed is actually really good to know. One thing that I want to mention here, and I'm going to clear this and make it a little bit bigger, is that most commands in Bash have actually a lot of help. So if you do man set, for example, this means manual and then set is going to actually give you what each thing means and what it does, okay? And then with that, you can actually try to build more complex searches that are out of the scope of this webinar. Okay. All right. Another really useful thing to know when you're doing bioinformatics, especially when you don't, is the first time that somebody gives you a Fasta or a Fastq, is to count how many sequences do you have, right? So we know, for example, that Fasta file headers always start with a greater than, and the Fastq files always start with an at. This is not okay. Is because for Fastq files, this is not very good because at is also a quality score. So you can have quality score lines that start with an at. So you need a more complex pattern to actually catch the names with Fastq. But let's start to show you a really useful command, which is called grep, using Fasta files. All right. So again, let's do head a Fasta. So we have our Fasta like that. Let's say that I want to check the headers only. So if I do grep and then I do the greater than and then the name of the file, what this is going to do is it's going to only print the things that have greater than. This is equivalent to do the awk, right? If you do awk pattern, this one, and then a Fasta, it should give you the same idea, right? So grep allows you to do all of that. So you can do grep SQ1, for example. This will only show you things that have the SQ1, etc., etc. So how does this help you to know how many sequences do you have? Well, grep has a count option. So if you give grep, so actually let's do man grep as well. So you can see all the options grep has. It has a lot of options. The one that I'm going to show you right now is C, which is count. It suppresses the normal output and it will print a count of the occurrences of that particular pattern, right? So if you want to count how many sequences in this Fasta, you're going to use U minus C. And this is going to tell you that there's only 32 sequences in this particular file. So grep is a very, very useful tool to have. There are other ways with other, to mix and match other commands, and some of you might already seen it. For example, you can have grep, right? And then you can pipe this to a word count. I mentioned word count briefly, but we haven't gone through it. So if you do word count minus L means lines, then it will give you the same thing. So let's try just word count with a Fasta to see what happens. So it will give us a more complete picture of word count. So the first one is how many words it has without spaces. Sorry, with spaces. The second one is without spaces. No, sorry. The first one is the number of lines in the full file, right? The second one is the number of words they has. In this case, is the same as the number of lines because there's no spaces in a FASTA file. And then the number of characters it has, the full file. So when you do grep greater than, what you are doing is you're subsetting the number of lines that we have. Okay, going to clear again. And go back to the presentation. So as you see, we did it with things. So what would happen with Fastq? I'm actually not sure if this, let's see. So if I do grep at, and then I do write norm. Actually, I'm going to just give a caret, and I'm going to explain what this means. When you put a caret in a pattern like with grep, this means it has to be at the start of the line, right? So if we do that, this is going to be a long thing. But as you see, this one is a sequence name, but this one isn't. So if we count directly with this, we're going to have count more lines, more sequences that you actually would like. So in this particular case, because we know either you know the pattern that you want. So for example, what would happen if I do, yeah, well, yeah, either you put a full thing, like it includes, for example, you can pipe this to another grep if you want, that contains 2, for example, then up. This is escape. If you do this is at the end. Oh, okay. I'm counting here, so I don't want, it's not outputting. So now everything that is showing most of it, what it is there, right? Because we know that this pattern exists. If you do not know and you are working with a Fastq file, right? Then one option to do it is just to print a division of the number of lines divided by 4, right? Because we know that most Fastq files have 4 lines per sequence. So let's see if we can do that. There is a print statement in bash that is called echo. So if you do echo, my name, for example, Sergio, then it will just print Sergio, right? But you can also say echo, and then when you do use a $sign in bash, normally means a variable or a special kind of operation. So if we do like this, and then we do, let's say, 20 minus 10, is going to do the mathematical operation that it is there. This space is important, okay? Now, if we want to use, we can use also word count minus L a Fasta. Oopa. Okay, so let's try it out by itself. All right. So we know that it's 224 lines. So what we can do is we can use 224 divided by 4. All right, and we know that it's going to have, oh, I am doing the wrong one. Sorry about that. So I am going to do word count minus L, right? FQ, so it has that many lines, so I can just transplant it here. And then I know that it has 5,593 sequences, roughly, okay? So let's try again with the grep and see if we can match that. So we have this one. That we think it's fine. I'm going to make it a little bit smaller so you see just in one line. In one line, and then I can just do -c right here, and it matches. I don't know where it will go, but I think it was exactly the same. Yeah, it's exactly the same. All right, so that's a way to count lines using just grep, and when you have multiple things. There are ways to not pipe with grep, but that's a little bit more advanced. Again, I encourage you to use the manuals. It will give you a lot of information about how to use grep with different patterns, etc., etc. It's a very versatile tool that you can use a lot in your bioinformatics pipelines. All right, another often we question if sequences are unique. All right, we need to know how many we have that are unique, because sometimes somebody concatenated files, etc., etc. So we can use commands like grep and sort to do this. So again, we can do grep, and then let's grep the greater than for a Fasta. Grep a Fasta, right? And this is again going to give us only the headers of that. But if we pipe it to sort and only sort, what is going to happen is it's going to try to sort, only literally sort the things that are there. All right. So if you use some of the options of sort, if you do man sort, you're going to see there are plenty of them. I'm going to show you right now the U option, which is unique. Okay, it will check if the sequences are unique. Okay, now if I do -u, is going to give us the sorted sequences that are unique, and is going to remove the ones that are not. So you can actually then pipe this to the W count -L and have the number of things. In this particular case, it does not have any duplication. Let's test that. Okay, let's concatenate a Fasta twice, and we're going to put a duplicate.fa. All right, so let's make sure that duplicate.fa, yeah, it is the file. And now we're going to do the same, but first just without unique. So we have 64, exactly double that. But if we use the unique, then we're back to 32. All right. In Bash, you normally always have to sort before you can do any other operation, set operation, because it requires to be sorted in order to be able to identify duplications. Okay. Another way that you can use, if you don't like sort -u, there is also a command called unique, and it will give you, oops, sorry, and it will give you exactly the same output. I normally use the sort, so it's one less pipe to worry about. It's just an option from sort. All right, so that's also very, very useful. I use this all the time. Every time I'm exploring for the first time a file, a Fasta file, or a Fastq file, I will always use grep and sort to count and to get the headers. Sometimes I only want the headers to be able to know, to query or to do stuff with those. Right? Let's imagine that we want to make a Fasta sequence single line. That's a lot more complex, and we can use this awk code. So Most of you are going to say, what the hell is going on in there? And there's a lot to unpack there, but it's actually not as complex as you might think if you explain it line by line. So let's do that. Right, so we have the code just breaking up in different lines. So we have a sequence, a Fasta file that has sequence 1, some multi-line sequence, then sequence 2, multi-line sequence. And what we want to do is that we want just header and then a full line of sequences. We don't want it wrapped, okay? So what can we do? So let's break this down. The first part, it's find lines that start with the greater than, right? That's what we were doing with awk before. So I'm going to jump here just real quick, just to show you again that. So if I do awk, and then I do greater than, and then a Fasta, then what I'm going to do is just be like, just basically what the same that I did with grep, but with awk. Okay, so see that that awk can be can have blocks. So the first block is when I find this. What do I do when I find this? Okay, let's check it out. What are we going to do? So first is print s, and I'm going in a second. I'm going to show you what s is. Print s, an end of line character. This /n means an end of line, an end of line. So like just the caret here, like this, the character that will represent that you're breaking the line right there, and then the line. So is s the actual end of line and the line, the full line. If s is set, this question mark here say is s set. If s is set or exists, is not empty, right? Then it will do this. Otherwise, if it's just s is not set, it will print the full line. And why is this important? Because we're going to set s later on. In this case, the first time that we see this line, we want to ask s exists. If not, just print this line. But if we are somewhere over here, right? Like, and we just finished this line, and then we go to this. We're going to enter this particular bit, okay? Because we're in the second thing. We have set s before, but we haven't printed it yet. So before we actually print this line, we need to print s first and then this line. Okay, that's basically what this line is doing. Then I'm going to reset s to be an empty string. And then I'm going to go to the next line. All right. Now, to the next line. So now I am in one of the sequence lines. I'm just going to say set s to previous s, which is this one, and 0. Okay, so the line, the actual line that is there. That's what we're going to do is append the line to s. That's basically what this line does. All right. And then at the end, when everything is done, so I went over all the file, I'm going to, if s, so if s exists, print s. And this is the case in which the last the last sequence will not have this block to print. So I need to actually print the s right there. Okay. So this is basically what it does. So now let's see if it works. So I'm going to, again, I'm lazy, so I'm going to just copy and paste it because it's quite long. So let's recap, head a Fasta. So this is a multi-line, you see that is wrapped. Now if I use a Fasta and then head, now this, there is not wrapping. Like it looks wrapped just because there's no enough space in my monitor. If I make it smaller, let's make it smaller. We will see, if I make it smaller enough, you can see that it's a single line, right? So the wrapping is artificial. And then we just have a single line Fasta instead of a multi-line Fasta, all right? Which with a single command is fairly fast. So you don't need to worry too much about it. So again, awk, if you are interested in learning something from Bash, awk is one of those things that can be complex to learn, but once you know it, it actually opens up a lot of avenues for you to explore. It is a very, very, very full programming language. Now I prefer other programming languages, but awk is one important one that is always present in Bash, and you can have just simple one-liners that you don't want to create a script, of a Python script or a Perl script or a C program to do. All right. Now another more or less often task that you would like to do is to convert a Fastq into a Fasta. Okay. Can you do that in pure Bash? Yes. And set is going to be your friend right now. And this seems odd, but I'm going to explain it little by little. So first of all, let's check what is n in set. So let's clear this up and use man set. Ooh, I think I'm going over time here, but hopefully I'm going to finish soon. So if I go to check n, n is quiet or silent. It will suppress automatic printing. And it's because set will always print the line that you're searching for. So we need to silence that. Then this part, which is 1 to 4, is going to read the file in chunks of 4. So from 1 to line 1 to line 4. And when I'm doing this, I'm going to search in a string for an at, right? And I'm going to replace it with an at the beginning. And I'm going to replace it with a greater than, okay? And then I'm going to print this line. And then I need to print, because I already printed this one, I'm also going to print the rest from 2 to 4. I'm just going to print it directly. So let's see if it works. Of course, there's going to have some issues there. So for example, the pattern, as we saw, the starting at, it will have an issue. But for now, let's make it easy. I'm sorry. And you can see that actually it worked fairly well. There's going to be some issues when the sequence the quality starts with an at. So you can actually create a more complex patterns right here. Since it's a little bit late, I'm not going to get into those details. But yeah. So there's a program to do all this. Actually, there's many, but one that I like is called Sequit. I was going to take a look of it, but we don't have time to deal with it. But most of the things I send you here can be done with Sequit. So I'm going to just show you a couple of things. So one Sequit, if you do -h, is going to give you a lot of different programs that it has. If you check the web page, it also has table of contents, what subcommands does it have, and it normally has explanations of the command and how to use it with some other options. So one that is quite useful is stats. So if I do seqkit stats and then a Fasta, it will give me the name of the file, the format, the type, how many sequences, the length of the sequences, the minimum length, the average length, and the maximum length, which for a Fasta file is not as complex, but it also works with Fastq files, all right? So it tells you that the format is Fastq, how many sequences, the length, the minimum, the average, etc. It's a very versatile and very fast program that you can explore as well. I just showed you how to do it directly with Bash, but you can also use this particular program. I have it installed in my computer. It's not yet loaded in our Compute Canada clusters, but you can install it in your home directory as well. So yeah, some other useful resources. There are a plethora of resources, but there's a few that stand out. The first one is Stephen Turner GitHub one-liners. It just gives you, actually, I'm going to just show you real quick. It actually gives a lot of single lines that are very useful for bioinformatics or for other stuff, but also for bioinformatics. And it will explain more or less what do they do. So Ocken set for bioinformatics, etc. So there's a bunch of one-liners here that will actually be useful to you. So check it out. There's the Grimoire of Unix. This one basically is a compendium of things to like the basics of set, for example. So what is each thing? It has all the tips and tricks for for the things that we just saw. And there's also tutorials. This tutorial list will kind of like summarize some of the things that are there to know and with some comments. So you can actually go here if you want to brush up your bash skills. All right. So with that, I'm going to open for just a couple of questions since I went over the time.